Hello everyone, welcome back to the channel. Today we are going to understand difference between replication, sharding and partitioning. So let's understand first what are these various concepts. First is replication, which you might have encountered in your day-to-day uh, work basically. So first say you have an application contains database, right? So you have a primary database and then you might have replica copies as well. When we say replica copies, the whole data, the complete data of the application is replicated across the nodes. So as you can see, this is my primary node. When we say primary node, any writes, it becomes a master. Any writes actually goes to this particular primary node. And then from this primary node, the replication occurs. So this replication, the basic goal is obviously high availability, fault tolerance. In case primary node goes down, then the replica node becomes the master. And obviously read scalability. So you can have uh, applications basically doing the reads from these replicas. So most important point to keep in mind is every node has complete data. Okay, so if there are 100 rows, I'm just taking an example of one table 100 rows, and all these also will have the same data. So this is the replication. It's a very simple concept. Now let's understand partitioning. We'll go to sharding later on. What is partitioning? Partitioning, when we say we have application and then we have database basically. This database is a single instance. It's a single instance database. Generally, that's what you see in the RDBMS, etc. Then you have a table basically. Uh, you could say a very big transactional table where you might have data for every day, every month. Okay, and it could be millions of rows. So we have this concept of partition where the same table in the same table there would be only one single table, right? In this single table, it would be divided into various partitions. It's still a single table, but divided into partitions, and also it's only one single database. Okay, just keep that in mind. That is partitioning within the table basically, and within the single instance. So that's partitioning. So partitioning would be like using hash, range, etc. So when we say range, it could be like say I might say for it could be like quarterly partitions, as we can see here, Jan to March, April to June, July to September. So whenever there is a query which is being done on this table, then obviously that particular partition will be queried. It is faster, but then obviously it is part of the same database. And obviously some maintenance operations also, etc. That is the advantage that we get with the partition. So again, data is split into parts within the same database. Just keep that in mind. Now we move to sharding. Now this is basically quite similar to partitioning, but now things will change. Here it was same table, same database, correct? Now here thing is I have this data. You could say same data, like for Jan to March, I might put it into one shard one. April to June, I might put into shard two. When I say shard two, it's different node basically. It's a different server itself. There it was single instance. Here it's a different node. Node is basically another server. So this is node one, node two, node three. Now that is called a shard. Shard one, shard two, and shard three. Every shard will have a different kind of data. When I say different kind of data, basically different set of rows. So say part shard one will have data for Jan to March. Shard two will have data for April to June. Shard three will have data for July to September. Something like that. Or it could be based on any key or hash value that you provide. Okay. So every shard contains a subset of data. When you uh, take the cumulative of this data, then you get the complete data. Otherwise, it's only a subset of data, every shard. And how this actually helps you because it provides horizontal scalability. Now, how does it provide horizontal scalability? See, when you query a particular data, say you query a data for Jan to March, okay, then it will only hit shard one. If you insert any data which is between January to March, it will only go into shard one. Shard two and shard three are unaffected, right? So that's the advantage that we get with the sharding. We'll understand with one more example for sharding. So this is just one example. They have done the range partitioning, okay, of the customer IDs. Say from 1 to 1 million, it would be in shard 1, and in shard 2, 1 million to 2 million, and shard 3, 2 million to 3 million. So this is my range partitioning that I have done. And suppose if there is a query which is between this range, then it will only hit this shard 2. So now we are actually dividing the traffic as well. So that's the advantage. And plus, if there is a new insertion between, say, suppose between 2 million to 3 million, then obviously it will be inserted into two shard 3. So here, when it was one database, and say it was 100 million reads or 20 million writes, so it was happening on one server. So that's what we have seen uh, in the first part, right? So in not exactly the replication, but the primary database actually handles this kind of load. Now, in a bigger system, it becomes a very big bottleneck to avoid that and to divide the traffic basically, so that the server load can be divided. You create this shard, you create this shard. So it would be shard 1, shard 2, and shard 3. Now you have divided the traffic here 30 million, 35 million, 35 million, 7 million, etc. Okay. So this is called as sharding. So obviously these are the advantages that you get with sharding, which is horizontal scalability, and every node contains a different subset of data. Apart from this, obviously sharding, you can also do sharding based on a region. Basically, you could do geo sharding kind of thing. Say Netflix, right? So Netflix might uh, have separate shard for say India users, shard for Europe, shard for any other region, say America. Okay. So now, if there is any user who is from India, only this particular shard will be queried or basically accessed. Say this shard is lying in the India region. Could be in Asia, anywhere in Asia, which is closer to India, right? So obviously your network latency and everything considering that your uh, basically your latency is reduced. And similarly for Europe and America, so they are aligned. So this is called a geo sharding. In that case, we actually put the shard or the node in that particular region closer to the user. So that is called as geo sharding. Obviously, it is not necessary that we might be doing it in all the cases, but then this is also one of the ways that sharding can be applied. And obviously, to take care of the cross-region replication, etc. Say like India's data is also available in the Europe region, so you might have a replica here. America's data is also there in India. All those kind of stuff. Then you might have cross-region replication as well. So that is also possible. So this is this is all about replication, sharding, and partitioning. Do let me know how did you if you like this video or not. Thank you so much.